Hi, this is the first video in a short series of videos that I've put together to show you how to create a Windows and Linux mixed OS containerized application using Docker Swarm. Throughout each of these videos, I'll be using an example application that I created with a Windows front end and a Linux backend. In my case, the application will be running on a 3-node cluster hosted in Azure. I'll have 2 Windows nodes and 1 Linux node, all VMs in Azure. The Windows nodes will of course host the front end of the app, the Windows-based portion of the app, and then the Linux node will host the back end of the app, the Redis data store. Now for clarity, I've split this demo into 3 main parts. In the first part, I'll be showing you how to initialize a Swarm cluster. So in my case, I have my 3 nodes running in Azure, and what this will involve is choosing one of the nodes and executing a very basic Docker Swarm init command from that node. From that point, that node will become the Swarm manager for my cluster. Then I'll be able to add the other nodes in my cluster, the Windows node and the Linux node, to the Swarm using a Docker Swarm join command. In the second part of this series, I'll be setting up the application itself. So at that point, I'll have my Swarm cluster all up and running, and then I'll just have to create the overlay network for my services, and then to deploy the front end and back end services for the application. Finally, in the third part in this series, I'll show you how to scale and load balance using Nginx. So in parts 1 and part 2, I'll have set up the application with just one container instance backing each of the front end and the back end services for the application. In the third part, I'll take the front end web service, which was only running 1 container instance, and I'll scale it out to be running 3 container instances. At that point, I'll also show you how to set up an external load balancer, in this case an Nginx load balancer, to distribute traffic across the 3 container instances that are currently composing the web service. Okay, so before diving into the demo itself, I'd like to show you a quick infrastructure view of the application, just to make sure it's easy for you to follow along. So as I mentioned, I'll have 3 container hosts. 2 of the hosts are Windows and 1 of the hosts is Linux. All 3 of the hosts are VMs running in Azure. And they're all connected to the same network, which means they're all routable to one another. The application itself is one application with a web front end and a database backend. Again, the web front end is Windows-based and will be running across the Windows nodes, and the database backend is Linux-based and will be running on the Linux node of the cluster. The web service front end is based on a windowsservercore container image, and the database backend is based on a Linux-based container image running a Redis data store. Now the container instances defining each of these services will be connected over a network called HelloNet. Now this network is an overlay network that uses VXLAN encapsulation technology to simulate a virtual network that spans across these hosts. When we create these services, we'll create them to be attached to this HelloNet overlay network. Okay, so now that we've taken a look at the setup of the application, we can move on to the deployment steps to make this happen. Again, in this video, we'll be covering how to set up the Swarm cluster itself. So once again, my cluster is made up of 3 hosts altogether, 2 Windows hosts and 1 Linux host. I'll show you those hosts now. So here's my Linux host. I'm accessing it running in Azure. I can show you the version of Docker running on here. And then I have my Windows hosts. Kali 1 and Kali 2 are the ones that I'll be using for this demo. Again, I can show you the versions of Docker running on these. Okay. So I'll be using Kali 1 as my manager node, Kali 2 is one of my worker nodes, and then the Kali 4 Ubuntu VM as my last host. So in order to initialize my Swarm, I need to use this Docker Swarm init command. The advertised address here and the listen address here use the IP address of the node that I would like to use as my manager node. In this case, that's my Kali 1 node, and the IP address is 172.170.19. So let's go ahead and do that now. Okay, so I have the Docker Swarm init command ready over here in my notes. I've also added this bit on the end to cause the output of this command to save to a file. I'll show you why I've done that shortly. So first I'll just copy this, then I'll head over to my Kali 1 node and paste that. Again, I have to make sure to execute this Docker Swarm init command from a node that I would like to become a manager node for my Swarm. Okay, so that executed. We'll see a brief flash momentarily, which is the networking being set up for this node. Now we can go on and take a look at the file, the output of this command. Okay, so this is the output of that docker swarm init command. It's letting me know that the swarm was initialized, and it's also giving me this command to add workers to the swarm. I can add managers to the swarm as well, but in my case I'll just be joining the other two nodes in this cluster as workers. So now I can go ahead and copy this. First I'll reformat it a bit. Okay, so now I can go ahead and copy this join command and go to my second swarm node, this Kali2 node, and I joined it as a worker using that command. I can do the same thing with my Linux node, simple as that. Exact same command was used for both nodes. And just to make sure you understand the syntax of the command, it's just docker swarm join and then a token that's unique to the swarm itself. And then at the end we have the IP address and a port upon which the node that we initialized as the swarm manager node is listening. And of course, now that we've added all three of our nodes to this swarm, we can go to our manager node and take a look at them all. We can do a docker node ls and list the nodes that are all part of the swarm. So as you can see, we have Kali1 and Kali2, those are the Windows hosts, and then we have Kali for Ubuntu, which is the Linux host. The leader is marked here, so Kali1, as we know, is the manager node for this swarm. And then it's also starred here because that's where I ran this docker node ls command, is on the Kali1 node. Alright, so if we return back to my diagram here, we went through the step of initializing the swarm from one of my nodes, and then also adding the two worker nodes using the docker swarm join syntax. And of course you can view the nodes using the docker node list command. Now the last thing we'll do in this portion of the demo is label our hosts. So again, since the example application here is a mixed OS Windows and Linux application, we need a way of telling Docker which of our nodes are Windows hosts and which of our nodes are Linux hosts, so that when we create services, we can specify where those services should be run. So in the last part of this demo, I'll quickly show you how to update nodes with labels. And in this case, we'll be using labels to denote whether each of our hosts is a Windows host or a Linux host. Okay, so I'll grab this simple command from my notes. Then I'll head over to my Windows Manager node. Then I'll paste it. And all this is docker node update. I'm adding a label. The label is OS and the value is Windows. I'm adding this to my Kali1 node. Then I'll do the same thing to my Kali2 node, which is also Windows. And then I'll add a Linux value label to my last node, Kali for Ubuntu. And then I can use the docker node inspect, and I'll choose my last node, Kali for Ubuntu, to see that this has been added as one of the attributes of my node. If I go up to the labels section here, you can see OS Linux was added. Okay, so at this point we've initialized the swarm. If I go to my manager node and I run docker node ls, you can see the three nodes in my cluster, Kali1, Kali2, and Kali for Ubuntu, all ready to go. And we even labeled them so that when we get to the point of creating services, it's easy for us to specify whether or not the service should be running on Linux or on Windows. Okay, so let's review what we covered in this video and go over what we'll be covering next time. So in this video, we got to this point in our picture. So we have all three of our nodes set up and part of a swarm cluster, and they're all labeled, ready to be set up with our application. In the next video, I'll go over creating the application itself. And then in the third video, I will go over how to scale the application and set it up with an Nginx load balancer.